So good afternoon, everyone. This is Samit Bhattacharya here, and the instructor for the course Computer Graphics. And today we are going to have our second and last interactive session for this course. So like before, what we are going to do in this session is to discuss your queries, your doubts, and provide clarifications on any issues that you might have. Please note that we are not going to have any live lecture here. So please don't wait for me to deliver any lecture. I am not going to deliver any lecture in this session. Instead, I will be waiting for all of you to come forward, raise your queries if you have any, so that we can take those up for discussion. Also, please keep in mind that we are going to restrict our discussion to the topics that are primarily covered in the course. So please feel free to come forward and raise your queries. Good afternoon, Sampath. How are you doing? Okay, so I just like to repeat again. I think in between there was some network issue, so I don't know whether all of you could get me clearly. So we are going to discuss queries, doubts, if you have any such things related to the topics that are primarily covered in the course. If topics are not inside the course, then unless the time permits, we may not be able to take those up. So I request all of you to discuss or come up with issues that are relevant for the course primarily. Of course, if we get time, then we may take up other topics as well, if possible. So please feel free to come forward and raise your queries if you have. Also, please note that this is going to be the last live session for this course. So you will not get any further opportunity to interact with the instructor. So I request all of you to utilize the time and clear your doubts if you have any. Okay, Jayed Khan. If there is any important topic that are most probably to come in exam, unfortunately, I cannot point out any specific topic. I mean, whichever topics are covered, so questions will be coming from all the topics. So there is nothing which gets priority over the other topics. So my answer is that all topics are equally important for the exam. Prakash has come up with a very philosophical question. How computer graphics helps to build our nation? Well, this is something which is very difficult to answer, let me admit. I mean, computer graphics is part of one engineering curriculum which is used to teach engineers of specific discipline, in this case, computer science, so that they have a comprehensive and holistic idea of what they're going to learn in the domain of computer science and engineering. So beyond that, I mean, that can be considered to be skilling our young generation. I mean, that is the best answer I think we can think of. Beyond that, of course, this course was not designed to basically provide all sorts of knowledge and wisdom that is required for nation building. So it has specific focus, specific purpose, and that, even if that is small, that certainly helps in nation building. So I hope that answers your question, but I understand that the grandiose scale in which you probably are expecting an answer, that is probably not part of the curriculum design here for this particular course. Apart from skilling a group of engineers in domain-specific knowledge, which in turn, of course, again, to look at it at a very philosophical level, which in turn will help various disciplines. Probably that is what I anticipate. Okay, Srikesh Shetty, what will be the pattern of the paper? Well, so we are going to have objective type questions. So it will be of about 2.5 to 3 hours of duration. And there every question will be objective or short answer type. There will be no descriptive questions where you have to write a lot. So it will be mostly MCQ types, along with few where answers will be a single number or single word. Difference between vector and raster graphics. Yes, so these are part of the lectures, but still if you have not noticed that, let me just reiterate. Vector graphics is kind of representation technique where the components of an image are represented in the form of basic shapes, primitive geometric shapes. So image is kind of collection of geometric shapes, you can say. If we are representing an image in that way, then it is vector graphics. Whereas in case of raster graphics, we are representing the image in the form of a grid of points and the intensity patterns or the color patterns at those points. That is the difference. Rituparna Das. Good afternoon, sir. Can you tell us what kind of question? Okay, I've already answered this one in case you have missed that. So we are going to have objective type questions. It will be entirely objective types. No descriptive or subjective questions. I mean, no descriptive questions will be there. And mostly MCQ types, along with few where you probably need to fill up the blanks with single word or numbers. And the questions will cover all the topics that are part of the course. So there is no specific topic which will have priority over the others. And just for your information, so there will be different type of questions. So some will be testing your ability to recollect the concepts that you have learned. So recall type. Some will be based on the kind of assignments that you have done, and some will be based on your comprehension, ability to understand the concepts. So essentially, it will test your ability to apply the knowledge that you have acquired in the course. And some will be straightforward recall type questions. So all combinations will be there. So it's not that all will be tough or all will be easy. Yes, so some questions will be related to all the concepts that you have learned in the course. Some will be related to the assignments, weekly assignments, and some remaining a little portion of the questions, not the significant portion, little portion of the question will be judging or testing your ability to apply the knowledge that you have learned in the course. Okay, Jayed Khan, can you please tell me some topics that I can? Unfortunately, as I said, questions will come from all the topics. So, and there is no priority of one topic over another. So it will be overall 100 marks question, and you will be given 3 hours to answer. As I said, mostly objective types, and it will have directly most of the questions to be recall type. That is from the lectures itself, you can answer the questions if you have just gone through the lectures. Some will be related to assignments, weekly assignments, and remaining small portion will be based on your conceptual clarity. So if you just go through the lectures, then majority of the questions you should be able to do. That is what should be able to answer. That is what I can say at this moment. But unfortunately, I cannot highlight few topics which will help you clear the exam. But what I can assure you is that majority of the questions will be of recall type. So if you just go through the lectures, which I'm sure you are doing, then you should be able to answer majority of the questions without any difficulty. Okay. AK Gaming. In the Cohen-Sutherland algorithm, how many bit codes are used to represent a region? Answer is 4 bit. How? So it is for 2D planes, we have 4 bit code. So to indicate now, first of all, are you referring to any specific lecture or any assignment or what? Can you clarify whether it is part of any assignment or, I mean, what exactly you want to know?
Hello, sir.
Hello?
Hello.
Yes, please go ahead.
सर जब डिटेल्स भर रहा था ना एग्जामिनेशन के लिए, तो जब सिटीज सिलेक्ट करना था तो अलग अलग सिटीज सिलेक्ट किए मैंने, मतलब मुंबई, रत्नागिरी। तो मुझे मुंबई आएगा फिर सेंटर में, से कुछ डाउट नहीं होगा ना?
Well, these things I have no control over it. I mean, where exactly will be your exam center or whether there will be any issue or not. I request you to contact the NPTEL team. So I am not part of that exercise. So have you contacted the NPTEL team regarding your queries?
No, sir.
So kindly be in touch with the NPTEL team. They are managing the city assignments and other things. So I may not be able to help you in that if you have any issue.
Okay, sir.
Yes, so what we were discussing. Sorry, assignment 6. Okay, before that, Jayed Khan. No, there is no negative marking in the objective questions. Okay, so yes, so answer is 4 bit for Cohen-Sutherland algorithm, 2D Cohen-Sutherland algorithm, of course, which is indicative of the four regions, left, right, top, and bottom. And I think if you go through the lecture number 21, then this is clearly explained. So there should not be any confusion regarding this. For 3D algorithm, the number of bits is more, but for 2D it is 4 bit. Please go through lecture number 21, I think week 6. With examples, these are explained, and with illustrations. How does rotating a point move it from one position to another, assuming rotations around z-axis? I thought it would just change the principal axis in the local coordinate. Can you elaborate a bit on your question? Is it only rotation about an axis? And if it is rotation, certainly in rotation, the position changes in the plane. So, I mean, I am not clearly getting your question. Rotating a point, move it from one position to another. If you rotate a point around an axis, then suppose it's around z-axis, then xy plane. So the xy coordinate is supposed to change, no? If you are rotating it. Rotation, I thought it would just change its principal axis, the local coordinate. So rotation means changing position only. Otherwise, how do you define a rotation? When it will assume a new position. So I understand that you are talking about transformation from local coordinate to world coordinate. Is that the case? Karan, thank you, Karan, for this encouraging words. So I hope everyone else is also enjoying. But it's good to know that at least one of you are really enjoying the course. And I hope the remaining part also you will enjoy. Thank you. So coming back to the earlier question, so in rotation is defined in terms of change in coordinates. It's with respect to some axis of rotation. So if it is z-axis, then on the xy plane, from the initial position, it is supposed to go to some another position, which is the angular displacement theta, whatever is the angle of rotation. And change of principal axis is not very clear here, unless you are talking of transformation from local to world coordinate. In that case, certainly with respect to the world coordinate reference frame, some axis change takes place, but that does not mean that there will be no change in position. So unless the vertices change their position, the square will not appear like a diamond. It will remain like a square. So the vertices need to change their position. Now you are talking of origin or the vertices? So if you are talking of so of course this problem is not fully defined. So let me try to define it. So you are talking of an object which is a square. I am assuming that it is on the XY plane, as you mentioned, and assuming that it is centered around or centered at origin. Of course, that is not a necessary requirement, but still, for the sake of simplicity, if I assume that. Now, when a square can look like a diamond, of course, making a square look like a diamond is a bit stretch of imagination, but I assume that you are referring to some other shape. Even if that is the case, then unless you change the vertices position, it will not change its shape. So essentially your the appearance. So essentially you need to change the position of the vertices to make it appear like another shape rather than a square. Yes, the vertices change, not the origin. I missed 3 assignments. So I'll pass the exams or not. That depends on your performance in the other assignments, but I think there is a minimum requirement that you have to score certain percentage from the assignments. If you are unable to do that, then irrespective of your score in the exam, I don't think you will clear the exam. So if you are able to keep that minimum percentage from assignments, then you may be able to clear the exam. In the remaining assignments, if you can come up with better yes. So just to finish with this current query. So if you score well in the other assignments, which meets the minimum requirement, then you should be able to clear the exam, assuming that you are doing well in the written exam as well, final exam as well. Otherwise, I am not sure. Okay. Parnika by diamond, yes. So that is what I also had in mind. Okay, so let me assume that it is the case. So the vertices change their position with respect to the initial position. So that is what rotation means. And if the axis of rotation passes through the origin, then certainly origin remains the same. Good, Pandika, thank you for the clarity. Yes. So, I hope, Cottage, you got your answer. I mean, it's clear. Okay, so kinds of question I already clarified. If you have missed that, so it will be objective questions, entirely objective, out of which major portion will be related to basically the topics that are covered. So it will be recall type, and some portion will be related to the application of the knowledge, analytical type. So if you have clear concepts, then you should be able to do those things. And if you have gone through all the topics, then majority of the questions should be easy to answer. It is mostly MCQ type. Few questions will be having a single word or single number answers. Short answer type. So there is no descriptive answer type question. And overall time given will be around 3 hours, I suppose. And it will be 100 marks question. So that is the basic idea of the exam. So it should be easy to clear as per my understanding, if you have gone through all the topics. Now, the second part of your question is if you could give any application of data science in computer graphics. Well, computer graphics is primarily related to display. Now, you want to display, visualization of information. To be very precise. And now, while visualizing things, if you want to visualize certain patterns, those patterns you can generate using data science or learning algorithms, and then use computer graphics to visualize those patterns. Apart from that, in the algorithms, thank you, Cottage. Appreciate your understanding. Okay, so coming back to the previous one. So data science may be having not direct but indirect contribution to computer graphics in terms of how well we can display things, how well we can visualize complex things by identifying patterns and so on. Karan, that is what I said. So basically, what is our objective in computer graphics? To basically display something, to visualize things, visualize scenes. Now, the thing that we visualize, data science techniques can be applied to those things to generate the inherent data, which may help in visualizing things in a nicer way. So I can talk about in that broad terms, but beyond that, specifically for computer graphics algorithms, application of data science, only for rendering, not for identifying patterns for rendering, only for rendering, I cannot think of any data science application. Yes, so you can use that knowledge to basically come up with better visualization schemes. And for visualization, you require computer graphics. Say, for example, if you want to visualize large network traffic data, I'm giving a very simple example, or say molecular interactions, or say a very complex scenario, or to generate complex traffic flow in future smart cities. So there you can apply the basically data science techniques to, based on data, of course, to predict things, how this should look like and what kind of patterns are there. And then once those are obtained, you can use computer graphics techniques to render it on the screen. So in that sense, maybe you can say that data science may be relevant for computer graphics. But to emphasize it again, computer graphics itself is dealing with only rendering of objects. And their data science role is limited. And also, I would like to mention a few things here, which probably mentioned in the lecture as well, in case you have missed that, is that whatever we have discussed in the course is 3D graphics pipeline. Now, that is primarily meant to give you some idea of how a static image is generated. In case of animations, I mean, the pipeline looks a bit different since we have not covered that, so it's not part of the topics. Now, when you are generating animations, there are certain things that you can generate using data science techniques. Or when we are applying, say, we are working in some application domain, say, extended reality, which includes virtual reality or augmented reality. Data science techniques to basically solve certain problems, which then can be utilized. The solutions can be utilized for better rendering and better user experience. So at a meta level, yes, the domains are connected. And I wish you good luck in your endeavor to connect the two. Parnika, all the best. 70 Junita Thres. BTech in CST and want a career in animation. I find this course very exciting. Can I take it? Yes, certainly. If you want to make a career in animation, now you can think of it in two different ways. One is creating an animation using existing tools. I mean, there are many tools that are available, environments, tools. You may like to learn those and use those to create, to build your career. Other thing is you build a career as an engineer in the animation industry, where you will be helping in developing new tools and new ways to make animations, new and easier ways as compared to the existing ones. If you are interested in the latter one, then certainly you need to have a solid foundation of computer graphics and computer animation to succeed in the industry. If you are interested more on basically just as a user of animation tools that are already available, then this knowledge will be helpful, but it's not, even if a simple understanding of the graphics would be good enough. You don't need to go into any further details. Only an overview is good enough. Certainly having an overview will help you in both the cases, but if you really want to make a contribution in terms of an engineer, then you need a stronger foundation in graphics. This course is the beginning. Along with that, you have to take up other advanced courses. Advanced courses on graphics as well as animation. Okay, I got many interesting questions so far. We still have some time left, so please feel free to put in your queries, any query that you have. We can still take up a few more for discussion. Please note that this is going to be the last live session for this course, and there will be no further opportunity to clear your doubts in an interactive session. So utilize this remaining time. Please come forward, put in your queries if you have further queries. We still have about more than 10 minutes left. Okay, how is it difficult? Is it to translate OpenGL programs to other graphics technologies such as Vulkan? Okay, that is an interesting question. So, I mean, translation is not something which I should talk about. And these bulk, so if we are looking at the software stack, I mean, the Vulkan or DirectX sits atop one layer of OpenGL. So essentially, they are also using OpenGL as APIs for their functions. So if you are utilizing them, essentially you will be making use of at L1 level OpenGL APIs. OpenGL is a library, by the way. And when I write a program, I just call this library functions, as you will be seeing in the remaining. I don't know whether those are already covered or in the upcoming lectures, how to use OpenGL library functions in a C programming environment. And so this Vulkan or DirectX, they actually make use of these OpenGL library functions only. So the conceptually both are similar. It's not that they are totally different. They are all linked. Okay, now, okay, that's great, you got it. Just one more line of clarification that maybe others might be having similar question. So OpenGL is not a program. OpenGL is a library. You use a programming environment to call the library functions. So that you may do in DirectX program or you may do in a C program. I mean, OpenGL program is not the right thing to use. It's a library of functions. But when you are using it in different programming environment, probably the calling function will look a bit different. The nature may be a bit different, but at the basic level, all are same. I hope you got the idea, Karan. Yes, that's perfectly all right. Yes, you understood it correctly, Karan. So function calls will not change. I mean, the way functions are function. Yes, you can say in a sense function calls will change. I mean, the way they appear, the way they are used in the program may change a little bit, not significant, a little bit, but the underlying concepts will remain the same. And these actually, this is very interesting. So if you go through the OpenGL lecture, you will get to know that these functions are related to the pipeline stages. Whatever topics we are covering, these functions are related to those topics. So essentially, if you know the theory, you will understand the functions. If you understand the functions, you will be able to master any graphics programming environment that uses OpenGL library, including DirectX or Vulkan, anything. There will be superficial level changes. Of course, you need to go through them a little bit, but it should not be difficult for you to understand the concepts. And it should not take much time to understand the difference. So I think we have come to the end almost. Maybe I've got time for one or more couple of questions at the most. I really enjoyed interacting with you. I got to know a few very interesting and relevant questions. I hope I managed to clarify those to your satisfaction. In any case, although we will not be having any more interactive session, please feel free to come to me through email, or if you forward something to the forum, post something to the forum, I will get to know of your queries. Please utilize that route. If you have further queries which we may not be able to, or which we may not be able to consider in this session, I am always available to help you. Through mail, you can always contact me. We are almost towards reaching the end of this session. Maybe one more question we can take up if you have anything further. Otherwise, after a couple of minutes, we'll close the session. Before I forget, I wish you all the best for your exam. Those who have registered for exam, those who have not registered, Anyway, I hope that you have enjoyed the course, you have learned few topics, and that will be helpful for your future. Yes, my mail ID you can find from my, probably may not be mentioned in the NPTEL site, but I mean, if you simply perform a Google search on my name, you will be finding my website on the IIT Guwahati Computer Science Department page. There you will find my details. And from there you can identify my mail ID. It's anyway for your benefit. It's Samit, S-A-M-I-T, Samit @IITG.ac.in. Sorry? I could not hear. Did anybody ask any question? Okay, so I think we have come to the end of this session. Thank you all for joining and coming up with really exciting questions. I hope I could answer your queries to your satisfaction. Please feel free to be in touch with myself or the NPTEL team for any queries related to the course or the exams or other relevant queries. Wish you all the best. Happy learning. So can we close the session? Is there anyone from NPTEL team? Yes, so I think we closed. Okay, bye.